So good afternoon. My name is Ashwath. At Razorpay, I work on cloud and infra security and also helping out with AppSec. I also have Ankit with me. Okay.
Hey, good afternoon. I hope I'm audible. So, my name is Ankit Anurag. I'm the lead security engineer here at Razorpay. Here, I mostly look into security operations stuff.
Okay, awesome. So before we do anything, right, I think today we'll focus a little bit on what exactly is bug bounty, like what's the typical workflow of a bug bounty hunter. We'll start with the story, kind of talk about the basics of what, would happen behind bug bounty and how exactly to prevent against it, right? The lessons we learned and how did we automate, how did we set up the framework and so on. Okay. We started on HackerOne about a year ago, and for 9 months we were running in private mode. And what happened was one of our co-founders, Harshil, he was big into security, right? Apparently, during his college times in IIT Roorkee, he was he was doing bounty, and he was helping out multiple companies, right? So he's always been like, every time we go to a meeting, when are you guys going public? When are you guys going public? And we had passed the deadline a few times. So it is like May 23rd, we said, okay, fine. I think we're ready. It was a Monday. I remember very well. Around 6 p.m., we turned the switch in HackerOne from private to public. And Sandesh, who was just here in the panel discussion before, he said, okay, guys, this is final. We are never turning it back to private again. I hope all of you guys are ready, right? So we monitored for 15 minutes, nothing happened. So we were all like, we logged off and, 6 p.m. we are done for the day, right? 7 p.m. what happens is 5 app teams are like, so we have this incident response, which kind of takes care of all of the alerts, outages and everything. So 5 teams reach out saying, hey, we are seeing like a lot of error rate, something's going on. So then one of us quickly hop on the call and we quickly identify that, okay, this is somewhere related to, us going live on HackerOne. And around 10 p.m., the number is constantly increasing. And we said, okay, security team, everybody, we're a lean team. So everybody gets on call. Let's figure out what is going on. Let's document everything. So whatever fixes, we'll go repeat the same thing across the other apps as well. So that's basically the thought process at that time. And around 10 p.m., it had increased to 12 apps. And the incident managers are constantly like, hey, what's going on? Just give us an update, right? Because we need to go tell other teams and ask them to be better prepared and stuff. So we were up the whole night, by the way, and, trying to fix this one after another manually. And it was very tempting to go turn it back to private, but we were like, okay, now that we figured out how exactly to kind of take care of this, let's just, run through this, right? And while we were documenting it, we also said, okay, whatever we do manually and that works, we'll also start automating. So that's basically, that was our funda saying, okay, if 3 of us are able to do it manually, repeatably, then let's just go automate it as well. So by the next morning, we had like 23 app teams reporting alerts saying, hey, there's something going on, right? So basically for them, they keep monitoring the number of 200 OKs, which is like an OK status. And anytime they start seeing like a lot of 4xx or a 5xx error, then they're like, okay, my app is broken. They wake up everybody in the team and they're like, hey, my app is broken. So that night we were not the security team was not the only team that was awake. Like a lot of the app teams were also awake. And they were like, okay, whenever I open the website, it's working. Whenever I test the thing, it's working. But why am I getting this error rate? So that was basically, what was going on in their head. So we'll come back to the story. We'll tell you what exactly we did, what we automated and everything. Ankit will cover it in more detail. But just quick thing about Razorpay, right? So Razorpay enables payments for all of... So Razorpay enables payments for all companies. So the idea here is we want to take care of the finance part and the payment part for all of the startups so that they can go focus on their journey and, improving their stuff, right? So if you look at the number of companies that Razorpay helps out, there are like a lot of big brands and we have over 10 lakh plus merchants. So we are more in the B2B space. So that's the reason why you might not see like a lot of advertisements or, you might not keep hearing about Razorpay so often. And to manage all of this madness, especially, during COVID, there was a hockey stick growth because of a lot of push towards online and stuff, right? So to manage all of this, we have about 6 BUs, over 800 engineers, and the tech stack is spread out. We are all in on the cloud. We are a complete AWS shop. Right. So this is coming back to HackerOne and coming back to, what exactly we did, right? So we did choose HackerOne as our partner for the bug bounty program. I think there was a question saying, okay, in the previous session, why didn't you do it yourself? Because we didn't have the bandwidth, to be honest. Right. So we wanted to outsource some part of it, and HackerOne guys knew exactly what to do. If you look at the bottom, right, these are the rules and the regulations. So basically in the rules, just, send us a header saying, you're a researcher, just add like a HackerOne header. And in the email also just put in, we are hackerone.com, right? So we can quickly identify and say, hey, it does belong to like a bug bounty researcher and it's not attacker traffic. And the final piece is, we did mention this here, do not run automated tools. But, hackers are hackers. So, it does happen. So this notification was very interesting, right? So May 23, we didn't know what happened. Like, we were like, okay, we simply went and turned the switch to public, and how the hell are we getting so much traffic, right? So then we solved the mystery, because there's a Twitter bot that tracks every program that goes public, and so this is the Twitter handle, right? So this the disclosed H1, which actually goes and says, okay, here a program is public, and because of which, a lot of researchers, what they do is they want to find stuff easily, like the low hanging fruit. So you just like bombard teams with automated tools, right? So yeah, this is the typical hacker mindset, where even though we ask them not to run automated tools, I understand, it's good to kind of, use automated tools at some time, but just don't like bombard the whole company with automated tools, right? Because it does cause a lot of pain. So looking at the workflow of what a bug bounty researcher would do. So it's split into 3 phases, right? Phase 1, if there's razorpay.com, go find all of the subdomains possible. So, you can use multiple tools. So for example, if there's razorpay.com, find api.razorpay.com, dashboard.razorpay.com, social.razorpay. So all the possible subdomains. So that is phase 1. So then once you have a list of subdomains, then find all the valid URLs. So this is like, /robots.txt, /success, whatever, all of the possible URLs. And once you get this list, then go bombard it with attack payloads, right? So this is basically, if you trim it down, these are basically like the 3 phases. So, folks, do scan this hashtag, and, it'll take you to a Twitter page. And when you go to the Twitter page, do put in your favorite tool. So we have Suchit here, who's our red teamer. Suchit, do you want to put your hand up? So if your tool name matches his tool name, then you'll get like some swag. And, the first few folks to do it will get the swag. So here are the 3 phases. That is, phase 1 is subdomain enumeration. Okay, let me go back to the QR code. You can come a little ahead, and I'll pause here for 30 seconds. So 3 phases: subdomain enumeration, the name of the tool. Second one is to find the right URLs. What is the tool that you use? And the third one specifically, let's just focus on Burp. What is your favorite Burp plugin to get the payloads, or what is your favorite Burp plugin, right? So I'll probably wait here for another 30 seconds. All right. So that should take you to my Twitter thread, and just reply on that. So, okay. Did it work? All right, moving on. We'll come back to this. I'll show the QR code in the end as well. So coming back to our setup, right? Just taking a step back and coming back to our setup. So whenever you hit our endpoint, the first piece it goes to is like an ALB, which is an application load balancer. And we also have the web application firewall, or the WAF, that's tagged to it. And then it comes to our own self-hosted API gateway, which is based on Kong. So Kong is this API gateway where you can add like your custom plugins. So we have our authentication, authorization, rate limiters, and a bunch of plugins that's hosted in the second piece. And then finally comes the microservice, right? So now let's look at what would happen in the back end whenever, a person sitting on one machine sends like a bunch of traffic, right? So approximate number of domains, let's assume it's 500. And, there's a payload list, which is about 10K. And, for each of the valid URLs, let's say you send 5K payloads, right? So the system gets overwhelmed with 2.5 into 10 to the power 10. So just process that number for a second, right? 2.5 into 10 to the power 10 just by the power of one laptop, or whenever you run like a nuclei template or anything of that sort, right? Or whenever you run a chain. So these many payloads hit the system. So let's say, there's a Chotu Motu microservice, which, just gets like a few hundred requests per second. What would happen to that service, right? That is the big problem. So that's why, all the developers think that my application is down, but in reality, it's just bug bounty traffic. And why do the 4xx errors happen? Let's say, the URL is not valid, or, the URL is not, the erroring is not very done very well. That's where, this happens. Okay. So just looking at the impact on the microservices, you send all of these requests, let's say the WAF blocks, a majority of them, but still about 500K requests, or 5 lakh requests will get to the application load balancer. And, the microservice will still get overloaded with stuff. Right. So this is kind of the background. So the three pieces are, whenever bug bounty traffic, you'll get like 3 phases. Phase 1 is on the subdomain enumeration. Phase 2 is on the finding the valid URLs, and phase 3 is like the attack payloads. Right. So I'll hand it over to Ankit, and Ankit will do like a deep dive on how exactly did we handle the incident, what did the runbooks look like, what automation we put in place, and how to kind of scale it. Right.
Thanks, Ashwath. So as Ashwath mentioned, this, as the story goes, means on 23rd May, we were bombarded with such traffic of that number. And at the end of the night, perhaps early in the morning, we kind of got a hint of what it is that we will have to, continuously keep on doing right now if something like that happens again. But then we also thought that it cannot be our, it cannot be a part of our BAU activity. We cannot we run a very lean security team. So what we have to do is we have to go back to the drawing board and then perhaps see what are the things that we can control out of this scenario. So we had this thing clear in our mind that there are 3 phases that will happen each time when an attack or a traffic comes. So how we would now want to understand that if there are any of these phases on which we do not have absolutely no control over, and then if there are anything which we can do to at least stop or at least identify any things that are happening in any of the bucket of the phases. So as you can see in phase 1, it is mostly subdomain enumeration. We did not have much control over who does the enumeration, what tool is he using, and it's basically just a website that you need, and you can run enumeration tools on it. And perhaps it did not need us as organization to do anything on top of that. So for phase 2 and phase 3 are some things that we thought that yes, we can put some of our controls in these. But before doing that, we were very clear that we have to have some kind of objective. So before in the previous talk also, we heard the folks say that before you start doing anything, or let's say even when we start implementing defense strategies, it is very essential to know that what we are defending, what is our main objective. So our primary concern was that availability needs to be the key. At no point of time we would want our businesses to go down or our environment to go down just because there is a spike in, let's say, bug bounty traffic. But at the same time, we also had to tread the path, ensuring that we create good experience for the hunters, because at the end of the day, they are also working for our benefit. Whatever they find out is precisely what we need from them. So we did not want to have a principle that whenever we see that hunter or a researcher is sending traffic towards us, we do not want them to block it right away. So we wanted the researchers to have good enough experience. The third thing, and to ensure the above two perhaps, was to ensure that we have this categorization done in our end, which would give us information about some kind of information about the traffic that is coming our way. So if the traffic is legitimate, or if the traffic is coming solely from bug bounty, or in other scenarios, if the traffic is suspicious traffic, which is, let's say, coming from any other adversarial malicious intent activities. And on top of it, the most important thing that, again, a security team who runs lean in terms of the manpower is that you want to remove yourself from the processes once the process is set. So once you've done all the manual work, once you've figured out what you need to do, at some point of time, we also wanted to give the other team this responsibility to take this opportunity and run it through and ensure that there will be minimal intervention from the security team to handle these kind of attempts, and which we can do through self-served dashboard. So we wanted to have some kind of automations put on which there will be, let's say, minimum need of a security researcher to jump in terms of in cases where there is spike in traffic.
So just one point to add on, right? So availability, especially for Razorpay, is very, very important because if our systems go down, then doesn't only impact us, but it impacts end parties who are dependent, right? So for example, you won't be able to get your Swiggy orders or Zomato orders. That leaves like a lot of people pissed off. So that's the reason, availability is super, super important for us. While we're trying to, learn more on security, availability is super important. That's why, for most companies, the same thing, right? So while you're doing this, please do also be cognizant that, there are people just like you on the other side who are trying to prevent all of this. Just that one column.
So with the guiding principles in mind, we started with categorization of the traffic. So if you see what the general flow of the traffic is, that we have a core logger. We use Sumo Logic for it. All traffic comes to this core logging platform. And from there, we have built our threat intel tools in combination with AWS WAF and then some signatures that we have created internally. They help us to filter out the suspicious traffic that comes in mixed with all the traffic that is incoming. Once we remove or filter out this suspicious traffic, we are left with the bounty traffic. And on that bounty traffic also, we kind of distributed that traffic into two buckets. So one is good bounty and then another is bad bounty traffic, by which I mean that Ashwath mentioned a few slides ago that we created some rules and guidelines that we wanted the hunters to follow when they are testing against our organization. So in any traffic in which we find those identifiers, we label them as good bug bounty traffic. And in those scenarios where we do not find any identifier and the only option left with us to identify that as bounty traffic is to understand the payload pattern and then perhaps come up with a signature fingerprint, we call them as bad bug bounty traffic. Now, very brief definition about blue team. I know there are a lot of red teamers here and pen testers. So the blue team is kind of an opposite to what a red team does. So NIST defines us that it is a group of researchers who have the responsibility to ensure that the system of any organization is up and running. And it does that through three major phases. Speaking in context of our bug bounty issue, the first phase for a blue teamer is to detect. Means, first of all, we have to create some use cases and alert which gets triggered whenever something fails or whenever a count increases. Once we have that detection, we would want to remediate it. And then before remediating, we need to, again, talking in terms of bug bounty, we would want to, first of all, fingerprint it. Means if we have understood that the traffic is coming from a bug bounty researcher, we would want to have some kind of information that defines that researcher in a way that we can take, or we can at least decide that we want to take any action against it or not. So in terms of fingerprinting, we identify the traffic, we identify the IP signatures, we identify the payload pattern. And then once we have done this, it all boils down to answer the question that do we want to take an action against this particular traffic or not? And if yes, then what kind of action do we want to take? So that comes under the remediation phase of a blue teamer. So again, talking about the identify phase and remediate phase, what we did, as I mentioned, we had divided the bounty traffic into two parts. So we also divided the hunters into two parts. We're saying we defined the first part of the hunters as compliant bounty hunters, by which we meant that all those hunters who were sending us traffic which had information, which had some kind of identifier information. Let's say they had custom headers, they are using correct email information. If we find any of the identifier, we say that it is a compliant bounty hunter. Or else if they do not have any kind of identifier, we say it is a divergent bounty hunter. So at the end of this identity phase, what one needs to understand is you can answer this particular question, that whether the traffic which is coming in your environment, is it a bug bounty traffic? If yes, then what kind of bounty traffic it is. So that concludes phase identity, identify phase. In remediate phase, what we understood is that remediation has to happen at the WAF layer. So for compliant bounty hunters, as I mentioned in my guiding principles as well, we did not want the compliant hunters to have a bad experience, researching our environment. So for that, we ensured that we do not take any action against them. But at the same time, it was very, very necessary to have an internal communication spread out amongst our team, outside the security team, saying that, look, there are some requests that will come in your way and that you'll not find that it is not a logical request, but at the same time, the intent of that request is not malicious. So we'll not be doing anything against that. And for the divergent bounty hunters, what we decided is, on a case-to-case basis, we'll see whether we want to throttle the traffic that is coming our way, or else we'll have to block the traffic itself.
So just adding my 2 cents, right? So while we did the May 23rd attack, it was very simple. The first phase, which is alerting was already in place, where app teams were getting alerts whenever the error rate goes beyond a certain point. Then the phase 2 was identification. So this is where most of our intel and most of our IP was. And then the phase 3 remediate. Basically we have 2 weapons. One is you can throttle the traffic, where you can slow down the traffic that comes from a given person, or you can basically block. If they still don't listen, just go ahead and block, right? Block is like the last thing that we want to do. And, as a principle, we don't want to block payments for anybody, right? So that's the reason we really don't want to go ahead and use the block mode. But throttle is something that, we kind of rely on.
Yeah. So now that we know that what we have to do manually in terms of identification, we had to now automate it. So how do we automate this thing? So the first important thing is to create decision flows for every scenario. So let's say for scenario A, when that happens, what are the things or what are the steps that we are thinking to take? And we wanted to document each and everything, because that decision tree flows to create runbooks for ourselves. Those runbooks help other team members also to just look into the situation that has happened, look into the decision flow, and then immediately know that what are the remediation measures that they want, or the security team should be doing, or let's say the app team should be doing in those cases. And at the end of the day, we wanted to come up with some kind of self-serve dashboard on which, if anybody looks into that dashboard, he or she gets an idea that whether the traffic is identified correctly, and if it is, then what is the action that is planned to be taken on it. So in our particular scenario, what we did is we used Sumo Logic as our tool again. And then if you see, we had this upper graph already present. This is the graph which comes for all microservices error traffic. It gives you a view of all the error traffic that comes from the microservices. We built a very similar graph on top on this particular trend, saying that this is the pattern recognition that we have found, which is given when an H1 traffic shows or a HackerOne traffic shows an outlier. So for anybody who is looking these two graphs in conjunction, the only thing that they now have to see is whether they find any similarity between the spikes that they are seeing. Let's say in the first panel, the spike that comes for microservice error, is it similar to the spike which is from the H1 traffic error? So if the spike is from H1 and there is a similar comparable traffic spike in the overall microservices, it means that the spike that has been caused in the microservices is primarily because of the bug bounty traffic. Now that we have identified, what we used to do is, let's say a blue teamer identifies this, profiles it, takes all the fingerprinting information that he needs to take, but then still there was a decision pending that do we want to throttle it or do we want to block it? Even when we have taken this information, there was still a need to go to our DevOps team and then ask them to do the particular thing that we want. So let's say if we want to block the traffic, we had a block list at WAF, which the DevOps team had to update it so that that particular IP gets blocked. And the similar thing was to be done for throttle. But obviously it was not a scalable solution. We did not want to have that kind of dependency each time we have to take a decision. So we did not want to include DevOps in all our cycles of taking actions. So how do we automate it was the question. So again, we came up with a very simple framework. The primary objective of this framework was to enable the blue teamer to be able to do everything right out of the console or right out of the Sumo Logic console itself. So what our process now does is that it picks the important queries, it aggregates the fingerprint, and it then pushes it to an S3 bucket. That pushing is done through a schedule forwarder. This is a feature that you get from Sumo Logic. So it's very similar to anything that a logger will, any of the loggers gives us this feature that you aggregate whatever information that you need to aggregate, and then you just forward it to a bucket. Once we have those aggregated information in the bucket, we wrote another cron job, which would push those aggregation to the WAF list, and then the WAF list gets automatically updated. So here we removed that dependency from DevOps, and then we ensured that each time the schedule search is running at Sumo, the WAF list or the throttle list and as well as the block list gets updated. So this is the final confluence or the final dashboard that we created. The main idea which drives this dashboard is, irrespective of who is looking into on this dashboard, you will be able to understand or give answers to 3 questions. First of all is whether the traffic coming in our environment is the traffic a bug bounty traffic. If it is a bug bounty traffic, is the bug bounty traffic a good bug bounty traffic or a bad bug bounty traffic? And if it is a bad bug bounty traffic, what is the kind of action we are wanting to take? Is it that we want to throttle it or we want to block it? So having had this confluence, we also, there was creating everything is kind of a continual learning process. It did not happen once, overnight. The queries needed to be matured. And so there were some lessons that we learned along the way, and then we kept on feeding it back to our original query and making it better and better. So Ashwath will talk more about the lessons learned as well as some key takeaways from the whole activity.
Sure. Thank you, Ankit. So just going back to the previous slide, right? So basically this is the money shot. So the reason why this is the money shot is it will give you all the information in one place. So the 2 things that you want answers for, right? So once you see an error rate, a developer would want to say, okay, is this HackerOne, is this bug bounty traffic or no? Right? So that's the first question that they want to answer. If that's the first question that they answer and the answer is yes, then the second question is it a good bug bounty hunter or a bad bug bounty hunter? Should I do something about it or no? Right? So those are basically like the 2 questions. And it'll give you clear answers to both those questions because, if you look at the bottom, the panel 4, right? The bottom right graph, that'll tell you where the spikes are so they can superimpose with the previous graph and they can take a decision. So then the top graph will tell you like the list of IPs that are sending like a lot of traffic, right? So it's basically a self-serve and the security team doesn't get into the loop unless, there's something new that's come up or, if they want us to take immediate action. right? So we basically got ourselves out of the loop. My mentor a long time ago gave me like a brilliant piece of advice. The advice was always try to replace yourself. So that you can move on and do something else, right? So that's basically, what we tried to do here was make as much self-serve as possible so the incident response and the developers could go run with it. So the next piece is, just the lessons that we learned. So continuous feedback, like Ankit mentioned, continuous feedback is important because the payloads keep changing. So you'll have to upload your payloads on the list where you identify whether a traffic is good or bad, or if it's from bug bounty or no. And also the methods keep changing. So we keep on top of it. And the one thing that we learned was, most tools do promise that we are very good out of the box. But trust me, no tool will kind of block all of the traffic, bug bounty traffic right out of the box, right? So you need to fine tune the tool, or you need to kind of understand your environment and tailor fit it to your environment. Specifically, ours was super, super complex. B2C is a little more easy, but B2B is very, very complex because we have Kirana merchants, then there is Swiggy, then there is Dream11, right? So we need to treat each of those merchants differently. Right? Because Kirana merchant will probably give us like maybe 10 lakh rupees business, whereas Dream11 and Swiggy are so huge, right? So yeah, that's where things get a little tricky, and try to block things at the outermost layer, which is the WAF, so that it doesn't come into your environment, and try to kind of learn from the researchers also. Basically, the researchers are targeting your environment, so try to learn things there as well. So the key takeaways, right? First is know your environment really well, because know what is getting logged, and the headers that I was talking about, right? So most of the places, the one thing that we realized that the headers were not getting logged. Though the researchers were sending the headers, our logging was not logging that particular header. So that is also very, very important. And the second piece is around thinking like an attacker, right? So once you build all of these systems in place, we need to also kind of fine tune the engine to make sure that the system is working as expected. And then the final piece is focus on the self-serve and the automation piece. Okay, I think that is it. Any questions? We're around if you want to have. Go ahead.
So, with a platform like this, which can impact a lot of people if it goes down, I want to understand why it was, what was the decision behind, having this bug bounty program on the live environment and not using a staging environment.
Correct.
I have very limited experience on this, but still, what was the management decision behind making the actual website or the platform live instead of having a different platform for this?
Correct. So two questions, right? One is why staging versus why production, and two was what was the thought process behind going after it in production. So hackers don't go after staging, right? So staging is you're basically kind of avoiding risk, or you are trying to limit risk. Again, it was a long process. We learned along the way. Like, don't start by going public. You'll definitely burn your hands, and somebody will get fired, right, at the end of the day, because system will go down for sure. So start small, start with private, then start with private plus UAT, start with private plus prod, then go public. Public is big bang. Okay, next. I can take your question quickly. Okay, I think.
Hi, Shiva here. So my question is a bit different. So I want to understand, did you follow any guidelines to select the bug bounty platform? You selected HackerOne, but is there any framework or guidelines you followed to select the right bug bounty platform for you?
Good question. I think, we are going to write a blog post on how we did vendor selection process, not just for bug bounty, but for other things as well, because I think it will definitely help out others as well. But the reason why we went with HackerOne was, I think it was easy to talk to them, their engagement process, and also the researchers were really happy. Like, we didn't want to go with a platform where the researchers were not very happy with the platform, right? So essentially, if you flip the coin around, if the researchers are happy, that's when you get good bugs. The researchers are not happy, you won't get good bugs. Okay, next question.
So apart from basically bug bounty hunters, did you try bots or scanners? Like the same approach for bot or scanners?
So we do have scanners running in our system, but automated tools is It doesn't give you like the high quality or the high severity findings. Like the automated tools are just like medium and lower most of the time.
So I have two questions.
Yes.
One is that you mentioned about it's a journey, right?
Correct.
And we can't just go public. So, and you're from Razorpay, right?
Correct.
Yeah. So from Razorpay perspective, because a lot of stake once you go to public. So how much is the general time what took you to mature to this level? Second thing is that, what is the maturity? Because it's not only a maturity of identifying it. As soon as you identify, you also need to have that quick
Correct.
and not only remediation, it's a quick remediation, right? And you should be prepared for that quick remediation. That is second. And third thing is, sorry, asking too many questions, but when you talk about HackerOne saying that researchers are happy and all, so while choosing it, is it that you engage with them initially for a couple of years and then with your experience you did that, or it was a general on maybe a couple of times you work with them, or the kind of general discussion about on their sales page, what they do, or who all are associated? Was that
so
theoretical?
I think let me answer your first two questions. So the first question, I did talk about it during the start of my talk. I don't know if you were not there, but so the part two to the question is, I think we took about 10 months to mature to get to that place, but I would say just take time and make sure your processes are matured. And we have a very good testing our own dog food. Like Suchit, who's one of our red teamers, we made sure that he runs the pipeline over and over again through different IPs, and we're able to manage that traffic. That's when, we made the conscious decision to go public. It's not like, you can just go. If you do that, then you're basically down, right? So, yeah. I think this side of the, okay.
Yeah, hi. This is Prathamesh this side.
Yeah, hi.
So already I had three questions. Two you already answered. One is the only one is you were you're talking about a lot about engine and all of that, right? Which you had developed. Just want to know what sort of things you have added to stay ahead of hackers, because every day new payloads and everything is generated, and nothing. There are a lot of things are not public, and another question is, a lot of custom tools are being created. I use a lot of custom tools which ease up my work, but it's automated, but also on the other side it is mimicking what I used to do manually. So how you differentiate between those sort of traffic? And because I can also send you a lot of custom headers just via my bot or anything like that. So how you distinguish into that?
Okay, so taking your first part, as we were mentioning, means the whole process is not a one-shot thing. We need to keep on maturing it. So even in terms of payloads, as you were mentioning, it changes. And the first set of the payload that we use to create our outlier detection pattern also, it's not that it is then we did not stick with a static payload set, so as to say. We also have our own red teaming or pen testing teams who then again they use their own custom payloads, and they also keep an eye on new kind of payload sets that are there in the market and that are getting used a lot, and then we try and keep up with those kind of intel as well, and we kind of try and have a maturity cycle for our outlier detection pattern as well. In the same line, even when you say that let's say you also can create custom bots which will run it, so yes, and that is one of scenario where, let's say, your payload will be particularly different from what we have set and what we have done. But if you scale it up, if a lot of people are again using similar technique to customize that as well, but there's just not only the payload which will give your fingerprint, or let's say for that matter any of the researcher's fingerprint. Payload is a factor that comes into play when we are creating that outlier detection, but it is just not the only thing. It is still there's a lot of information in that request itself, and on which let's say URL or domain you're attacking, that also tags along when you create the whole outlier detection. So if you group or categorize everything together, you will still find a pattern on which you can train your model.
I
trainium
Let's
model.
take it offline then. They're asking, yeah.
Okay.
You also mentioned trainium model. So are you using ML as well?
No, so the engine that we use, Sumo Logic, right? It has a built-in ML module which we use to run. So it's not that we are writing our ML code itself, but more or less we are taking help of the already written ML piece that Sumo offers.
So thank you very much. And short answer to your question, we have our own red team where we eat our own dog food. So I think that's how we learn, right? So there's no right or wrong answer, and we're probably 98% there. So yeah, that's the short answer. Okay, all right. Thank you very much, everyone.